All right, uh, here we go. So I have a new system here that I think hopefully is a little bit better than the system that I was using the other day. I finally have a dot cam and a webcam and all of that stuff, so I can record this way. I tried to look up some videos about using algebra tiles to multiply algebraic expressions, and I didn't really find any that I liked super well. So here I go to make my own. It's not that the way that they did it was wrong or anything like that. It's just I think that this is really intuitive, and the videos that I saw anyway were sort of taking the approach of like, well, I'm just going to show you how to do it. I'm just going to teach you how to do it. But I really think it's more intuitive than that. I think you can pretty much figure it out for yourself. That's one of the beautiful things about algebra tiles, is that they're so easy to grasp, right? They're so easy to work with. So what I want you to do when we're going through these examples is to sort of forget that you know anything about algebra. Okay, so forget that you know that x squared, or forget that you know that x times x is x squared. Just forget that you know anything, and just use the tiles and let the tiles do the work. Let the tiles do the hard work. So I want to give you some examples of multiplication. Okay, so first example, let's do x plus 2 times x plus 3. And of course, you've done some reading on this already, and so you might have a good idea. Let me see if I can get that to, which one of these buttons is this? Oh, here we go. Let me see if I can get that to focus a little better. That's a little better. Okay, so x plus 2 times x plus 3. So the way that we're going to do this with algebra tiles is we're going to use an area model, just like we used when we were doing fraction multiplication. Okay, we're going to use an area model, which means we're going to try to represent x plus 2 along one of the sides, and we're going to try to represent x plus 3 along the other side. It doesn't matter which one you put where, because multiplication is commutative, right? So you can put x plus 2 down this way and x plus 3 across this way. And we want to represent these with algebra tiles, okay? So I'm going to do x plus 2 over here, and I'm going to do x plus 3 up here, but it doesn't really matter. Okay, so let me put my tiles on the board. So for x plus 2, I'm going to have an x tile, and then 2 units. For x plus 3, I'm going to have an x tile and 3 units. Okay, and so there we go, right? So we've got x plus 2 times x plus 3. Now, the answer to that multiplication problem is the area that results when you fill in this square, or this, well, it's not a square, but when you fill in this rectangle. And so what I want you to do is pause the video, okay, use your algebra tiles, and see if you can figure out what's supposed to fit in here in order to make a rectangle. I'll give you a little hint before you do that. The lines that result from the spaces in between the tiles, they have to extend all the way through the diagram. So in other words, I wouldn't put like a Y tile right here, okay? Because this line, that's a space between my X tile and my unit tile, it has to extend all the way through my diagram. And if I put a Y tile right there, then the line is going to get interrupted, okay? And that's not allowed to happen. So give the video a pause, right? See if you can figure out what goes in here. I'm going to go ahead and work out my solution. So make sure your video is paused if you're not done working out your solution. But here I go. All right. So, um, so again, forgetting that I know anything about how multiplication works with variables, right? So I'm not using the fact that I know that x times x is x squared. I'm just looking at the tiles themselves, right? And here I have a tile with length x. Here I have another tile with length x. So it seems like the tile that has to fit in this space has to have x, has to be an x by x, right? Has to be an x squared tile, right? That's the only tile that will fit there, okay? If I'm thinking about what should go in this space, right? In this space right here, it has to have a length x and it has to have a width of 1. Well, what tile does that look like? Of course, that looks like an x tile, right? The same thing goes for the other two locations there across the top. Okay, it must be this situation. Those are the only tiles, okay, those are the only tiles that will fit there, right? We still haven't filled it all in, right? Because we've got these two tiles down here, and so we still have some more rectangle we need to fill in down here. Well, now if I think about what should go in this space, it should have a width of 1, right? And it should have a length of x. Well, only one tile will do the trick for that, right? It's got to be another x tile. And same thing goes for this space down here. Okay, now for the remaining space that we have to fill in, you might be tempted to like try to use an X tile or something like that, right? So you might be tempted to say something like, oh, well, it looks like X will kind of fit in there, except that it doesn't, right? Because look at how much it's overhanging on this side, right? So the X tile doesn't fit in there. But also, you have this problem where these lines that are supposed to extend all the way through the figure, they're getting interrupted by this tile, right? So it can't be an X tile that fills that in. What tile should go there? Well, if I can't interrupt the lines, then I've got to have a tile that looks like this, right? That fits in that little space. The width of that tile is 1. The length of the tile is 1. That must just be a unit tile then. And the same thing goes for the remaining spaces, right? I'm just going to fill those in with unit tiles. Okay, so I've got 6 units altogether, but that completes my rectangle. Okay, so this is the answer to, this is the product, right? It's the answer to that multiplication problem. We would say x plus 2 times x plus 3 is x squared plus 1, 2, 3, 4, 5x plus 1, 2, 3, 4, 5, 6. Okay, so it's x squared plus 5x plus 6. And again, this just comes from manipulating tiles. We didn't have to know anything about exponents, right? We didn't have to know that x times x was x squared. We didn't have to know anything about FOIL, right? We didn't have to know anything like that. It just came from the visualization, right? It just came from the tiles themselves. We can verify that this is true, by the way, right? So to verify that it's true using what we do know, okay, so now let's use the algebra that we learned. Okay, so we would FOIL this, right? We would FOIL this. So we're going to do the firsts. X times x is x squared. We would do the lasts. X times 3 is 3x. We would do the inside. Or what did I say? I said first outside, inside, right? 2 times x is 2x. And then the lasts. Sorry, 2 times 3 is 6. And then you combine your like terms in the middle. Okay, remember like terms have to have the same variable and the same exponent. So the 2 in the middle are the only terms that are like terms here, right? 3x plus 2x is 5x. Sure enough. Okay. And for some of you, you might be thinking, well, this is way easier than the tiles. But imagine that you were seeing it for the first time. If you were seeing it for the first time, do you honestly think that this makes more sense than this? I think the tiles make a lot more sense, right? I think they're a lot more intuitive. So they're really good. They're really good tools, I think, for building some intuition. One more thing that I wanted to say about this particular problem is if you were having to draw this for like the homework, it's actually easier, I think, to draw this out than it is to do the problem. So I'm going to take away my answer real quick, and I'm going to show you how I would draw this. Let me erase this stuff. Okay, here's how I would draw this if I were doing this in the homework. Okay, now like I said, the spaces between your tiles have to extend all the way through the figure. So if you could even use a ruler to make it even easier, but if you just extend these lines all the way through, okay, and we've got a line there, there, and there. Notice that that's your answer. You know what I mean? This one is x squared. These are all x's. And these are all ones. You might be thinking, well, but how do you know to stop there? But it's because that's where the tiles stop. You know what I mean? Like you're limited. It's like you're bound by the extent of where the tiles fall, right? I mean, like this is the rectangle that you're looking for. So I think it's actually easier even to draw. Of course, you know, you'd have to draw the x plus 2. Well, that's not too bad, right? You can say, well, there's x plus 2, and here's x plus 3. Right, and there you go. Right, so x plus 2 times x plus 3 is x squared plus 5x plus 6. Okay, now I have to try to figure out how to stop this video. Here we go. Okay, stop recording.